Hello everybody. Today we're going to talk about inverse of a matrix, and we're going to have an example of how to apply this particular operation of a matrix in terms of solving a particular problem. Now, the symbol for an inverse of a matrix could be A raised to the power of -1, or B raised to the power of -1, or C raised to the power of -1, and so on, depending on the name of the matrix. For example, if the matrix is D is equal to 2, 8, 9, 0, the inverse would be D raised to the power of -1. Now, it should be noted that a matrix inverse is only applicable for square matrices. An example is 1 by 1, 2 by 2, 3 by 3, and so on. When I say square matrices, the number of columns is equal to the number of rows. A, for example, is 5, is a square matrix because we have one row and one column. B is equal to 2, 3, 9, 8 is also a square matrix because the number of rows is equal to the number of columns. And it can continue to 3 by 3, 4 by 4, and so on. Okay. Now, the inverse of a matrix becomes more complex depending on the order or the size of the matrix. If it is 2 by 2, it is easier compared to 3 by 3, of course, because 3 by 3 has 9 elements. So let's start finding the inverse of these matrices. A is equal to 1/3. The inverse of any 1 by 1 matrix is very easy to find because you have only one element. So basically, to find the inverse, we have to get the reciprocal. When I say reciprocal, this is the multiplicative inverse of any real number or any expression. So here our A raised to the power of -1 is equal to 3. That is the reciprocal of 1 over 3. And here our B raised to the power of -1, or inverse of B, is equal to -1 over 6. It is the reciprocal of -6. Okay, so it's very easy to find the inverse of any 1 by 1 matrix. Now here we have 2 by 2 matrix. We have 5, 3, 4, 2. Basically, the first step for any 2 by 2 matrix is to find the determinant. Okay, so that is that of B, because we have matrix B, is equal to left diagonal. We have to start with the left. That is 5 times 2 minus, this is always minus, 4 times 3, or 3 times 4, the right diagonal. So this will be -2, of course, because you have 10 minus 12. Now, the next step is to find the positions of the elements. Okay, so we have A11, that is 5. A12 is equal to 3. And A21 is equal to 4. A22 is equal to 2. So we have 5, 3, 4, and 2, 11, 12, 21, and 22. So going down is plus 10. Going to the right is plus 1. So 11 plus 1 is 12. 11 plus 10 is 21. 12 plus 10 is 22. I have discussed this already. 1, 1 means row 1, column 1. Okay, and of course, 1, 2 means row 1, column 2. And 2, 1 is row 2, column 1. 2, 2 is row 2, column 2. Right, so that's the first two steps. And the third, of course, is to write the formula. 1 over that multiply So here we have to tweak a little bit. We have to start with 21, okay, then 22, sorry, then we have 21, then we have 12 and 11. And these two should be negative. Okay, so basically what happens here is the swapping of 22 and 11. As you can see, here we have 11 and 22. We have to swap both of this. And a sub 12 and a sub 21, the same, but we're changing the signs. So you can see here we have negative and negative. So therefore, our b raised to the power of negative 1, or inverse of b, is of course 1 over negative 2, okay, multiply a sub 22. So we're going to swap 2 and 5. 2 will be here and 5 will be here. And our 3 will become negative 3. 4 will become negative 4. So the only difference is that we swap the position of 5 and 2. So 2 is here. We're going to move it up. That will become a sub 11 somehow. And 5 will go down. Is here. 3 and 4, the same positions, but we have to change the signs. Of course, if a sub 12 is negative 3, it will become positive 3. Okay, if it is positive, it will become negative. So now we have to multiply 1 by 1 inside. Okay. So our inverse is equal to, we have 1 over negative 2 times 2 is negative 1. And then we have 1 over negative 2 times negative 3 is 3 over 2, or 1.5. And here 1 over negative 2 times negative 4 is equal to 2. And 1 over negative 2 times 5 is negative 5 over 2, or negative 2.5. Okay, so that's the answer. We have negative 1, 1.5, then we have 2, negative 2.5. Okay, let me just write this properly here. Let's have more space. All right. So here this is equal to negative 2.5. Here 3 over 2 is equal to 1.5. So let's try this in Excel to check whether the answer is correct or not. Our answer is negative 1, 1.5, 2, negative 2.5. Let me take a screenshot of this. Okay. All right, so let me take our answer for you to see. So this is our answer. So the answer is negative 1, 1.5, 2, negative 2.5. All right, so let's try to use Excel to find the inverse of 5342. That is the given here. We have 5, 3, 4, and 2. Right, so I have written the numbers here. The first number is 5, followed by 3. Then we have 4 and 2. Okay. All right, so now we have here 2 by 2 matrix. Now here I put D, it can be any letter. It can be B or any matrix name. Now, since we have 4 cells here, 2 by 2, we need to select also 2 by 2 here to find the inverse. Right, so I can select any 2 by 2 cells here, for example, equals MIN, double click M inverse, select the numbers, Control Shift Enter. So as you can see, the answer is -1, 1.5, 2, and -2.5. So we have correct answer. Now let's try to solve another matrix, finding the inverse. Here we have 2 by 2 matrix because we have 5, 3, 4, and 2. How about if you have this? Find the value of x, y, and z using a matrix inverse. So how to solve this manually without a software? The first step that you're going to do, of course, is to generate the matrices. So let's start with matrix A. Matrix A actually contains all the numerical coefficients before the variables. So we have 2, 5, 9. Then we have 1, 3, 4. Then we have 6, 7, and 0. So here we have complete set 2x, so we have 2, then 5, 9. Here we have also complete, we have 1x plus 3y plus 4z. Here we don't have z or z. So as you can see here, we have 0. We have x 6 and y is 7. Okay, and our p is after the equal signs. We have 49, 26, and 53. So always we have to take or generate two matrices, A and B. All right. Now, the first thing you're going to do is to find the determinant. Okay, determinant of A is using the plus minus plus. Plus minus plus of column 1 only. You can also use row 1. Of course, it's going to give you the same answer, but it's easier to use column 1, this one. That is 216. So we have to start with plus 2, open and close. Okay, because we have 2 there as the first number and the sign is positive. So we have to copy the whole matrix 216, 5, 3, 7, 9, 4, 0. Okay, and then minus second sign minus 1, copy the whole matrix 2, 5, 9, 1, 3, 4, 6, 7, 0. Then the last is plus 6. We have 216, 537, 940. Okay. So as you can see here, we have plus minus plus, plus 2 minus 1 plus 6. So here we have the first number 2. We have to encircle that. And we have to delete left and right and top to bottom. So as you can see, the remaining is 3470. So plus 2 is 2. It will not change, positive 2. Then we have here 3 times 0. Okay, so let me just write it. And later we can write the answer, 7. So the remaining, we have 3470 minus 1. Now, 1 is the next value. So we have to encircle 1, delete left to right, up and down. So this will be 5970 as the remaining values. And the last is plus 6. We have to encircle 6, left to right, up and down. So the remaining is 5934. Okay. So this would be, okay, you have to use the left diagonal first. That will be 2 times 0 minus 28. You multiply 3 times 0. This is always minus 7 times 4. Then minus 1, 5 times 0, 0 minus 63, 7 times 9. Then plus 6, we have 5 times 4, that is 20, minus 9 times 3 is 27. So please use your calculator and give me the answer. So this is only the first step, finding the determinant. So put all of this in the calculator without any space. You're going to get negative 35 as your determinant. Okay, so the next step is to create a 5 by 5 matrix. So basically from 3 by 3, now it becomes 5 by 5. So we have 2, 5, 9, 1, 3, 4, 6, 7, 0. This is the original matrix. As you can see here, our matrix A, 2, 5, 9, 1, 3, 4, 6, 7, 0. Now, to make it 5 by 5, we need to add 2 columns on the right and 2 rows below. So that means we're going to copy the first 2 columns. We have 2, 1, 6, 5, 3, 7. And now you copy the first 2 rows. We have 2, 5, 9, 2, 5, 1, 3, 4, 1, 3. So as you can see, our matrix is now 5 by 5. So what you're going to do is to delete column 1 and row 1. Okay, so it will become 4 by 4. So from 3 by 3, it becomes 5 by 5. Then deleting column 1 and row 1, it becomes 4 by 4. So now we're going to create arrows. The first arrow is here, diagonal, second, and the third. And then we have here our fourth, fifth, and sixth. Then we have 7, 8, and 9. So basically, we have created 9 arrows, diagonal arrows. Okay, so we will now multiply to get our, of course, adjoint. We have to get the adjoint of matrix A. To do that, we have to, of course, multiply diagonally minus the right diagonal. So 3 times 0 is 0, minus 7 times 4 is 28, so negative 28. And then we go to the right. Okay, this is going down, but when we write, we have to go to the right. Okay, the next is 7 times 9, 63, minus 5 times 0, the 0 equals 63. And then we have 5 times 4, 20, minus 3 times 9 is 27, equals negative 7. This is for the first. Then let's go to the next 3 arrows. Start with 4 times 6, 24, minus 0 times 1, 0 equals 24. Then 0 times 2 is 0, minus 9 times 6 is 54, equals negative 54. And the last 9 times 1 is 9, minus 4 times 2, 8 is equal to 1. Let's proceed to the last 3 arrows, starting with 1 times 7. 7 minus 18 is equal to negative 11. 7 times 1, 6 times 3. And then 6 times 5, that's 30. Minus 2 times 7, 14 equals 16. Then 2 times 3 is 6 minus 1 times 5. So that will be 1. So we call this as our adjoint of A. The next, of course, is to get the inverse. The formula is 1 over that times the adjoint of A. So our A raised to the power of negative 1 is 1 over negative 35 times, put these numbers, negative 28, 63, and we have negative 7. And we have 24, negative 54, then 1, negative 11, 16, and 1. So we will now multiply this one by one. So we have to multiply 1 over negative 35 times negative 28, 1 over negative 35 times 63, and so on and so forth. Okay, so let me transfer this. Right. Okay, so here we have to put the answer. You can use your calculator, of course. 1 over negative 35 times negative 28. In your calculator, we can divide this one by 7. Yes, so see, negative 28 divided by 7. So 4 over 5. And then we have 63 over negative 35. You can divide again by 7. So it will become negative 9 over 5. So you can use the calculator for this, of course. You have to divide 63 by negative 35, then equals shift ABC. For other calculators, it is automatic. Again, manually, we can divide this by 7. So this will be positive. Negative by negative is positive. 28 divided by 7 is 4. 35 by 7 is 5. Here we can divide by 7, 63 by 7. But this is negative because we have positive and negative. 63 by 7 is 9. And 35 by 7 is 5. And here, negative 7, negative 35, it will become positive. So that will be 1 over, of course, 5. Because 7 by 7 is 1, 35 by 7 is 5. And then here we have 24 and negative 35. That will be the same, but negative. And then here we have 54 over 35. Positive now, because we have negative and negative. And the last one is negative 1 over 35. Okay, so the last we have negative 11 and negative 35. That will become positive. Here we have positive 16, so that will become negative 16. And the last one will be positive and negative, so negative 1 over 35. So that is our inverse. We have 4 over 5, negative 9 over 5, 1 over 5, until the last. Okay. Now, let's find the value of x, y, z. To find the value of x, y, z, we need to multiply the inverse and the b. So we have to multiply this inverse and our b. Our b is 49, 26, and 53. So that means we have to multiply this and this. So for your x, you have to take row 1 multiplied by the column here. So x is equal to 4 over 5 times 49 minus 9 over 5 times 26 plus 1 over 5 times 53. Okay, and then our y, this is our y, row 2, that is negative 24 over 35 times 49 plus 54 over 35 times 26 minus 1 over 35 times 53. Our z is equal to the last row, row 3, 11 over 35 times 49 minus 16 over 35 times 26, negative 1 over 35 times 53. So the value of our x is 3, y is 5, and z is equal to 2. Okay, you can check this in the calculator and see whether the answers are correct or not. Let's check our answer by taking one of the equations here. So our x is 3, so 2 times 3 plus 5 times 5 plus 9 times 2. This is 6 plus 25 plus 18. 31 plus 18 equals 49. So the answers are correct. I tested one equation here. We have 2x plus 5y plus 9z equals 49. Our x is 3, as you can see here. So 2 times 3, and our y is 5, so we have 5 times 5. Z is equal to 2, so we have 9 times 2. That is equal to 49. Okay, I want you to check this in the calculator and see or find the values of x, y, and z. Okay, let's try to have this in Excel sheet and see whether the answers are the same or not. So we have here our system. We have 2x plus 5y plus 9z equals 49. X plus 3y plus 4z equals 26. 6x plus 7y equals 53. So the first step, of course, is to find the matrices. So we have A equals 2, 5, 9. And we have 1, 3, 4. This is your x, y, and z. And here we have 6, 7, and 0 because we don't have z here. And our b, of course, is equal to 49, 26, and 53 after the equal signs. Our A inverse, and solve it here. We have 9 cells here, 9 numbers. So we have to select as well 9 cells here. Equals MIN. Double click M inverse and select the values, Control Shift Enter. Don't forget Control Shift Enter. You have to use 3 fingers. Now, see here, the answers are in fraction. Let me just check our answers here. Our answers are this. Let me take a screenshot of this. Okay, here. Let's test the answer. We have the first one is 4 over 5, so equals 4 over 5. Without number here. 0.8 is correct. And then we have negative 9 over 5. Negative 1.8 is the same. And then 1 over 5, that is 0.2. So the first values are correct. And here we have negative 24 over 35, negative 0.7, and we have 54 over 35, 1.5, and negative 1 over 35, negative 0.03. So here we can increase exactly same. For the last row equals 11 over 35, 0.31. Then we have negative 16 over 35. Okay, it's the same. And then we have negative 1 over 35. So it's correct. Okay, so that means our answer here is correct. Now let's find the values of x, y, z. We have to use matrix multiplication. So we have the b here. We have to multiply our inverse and the b. So select three cells opposite to x, y, z equals mm, matrix multiplication. Select the inverse, comma, select the elements of b, Control Shift Enter. So the values are 3, 5, 2, which are equal here. We have 3, 5, and 2. So basically what I have shown today actually are the manual methods and the solving process using the software, using MS Excel. So I hope you learned something. We have here inverse of 1 by 1, 2 by 2, 3 by 3, and we're able to solve a problem by finding the values of x, y, and z using a matrix inverse. So that's it for today. Thank you so much for watching. Until the next time, bye-bye.